an Irishman, an Englishman, and a Scotsman walk into a bar. If anybody knows the ending to the joke, let me know. I'll do it. So what else is up? I don't know anything. That was it. I know it in Greek, but it doesn't translate. What do you get if you cross a joke with a rhetorical question? That's a joke. Nobody got it. It's fine. I'm bombing down here. Do something. No, there's nobody's birthday today. Is it? Is it your birthday? Ah, how old are you now? 26? 26 going on 17. Alright, okay. Because in your bio you say 25, so you're lying about your age, man.
I know, we need to update it.
Today you were officially lying about your age. Alright, well, while we're waiting for Todd to get it set up, the title of the talk is From Component to Web Component, or something that, you know, if he changed it, that's not on me, that's on him. And Todd is developer advocate at Telerik, is that right? Yeah, okay. And also a developer expert at Google, and he does a lot of Angular training, and is about to talk to us about Angular 2. It's called Component Architecture. No egg on my face there. All right, take it away, Todd. Thank you.
Thank you.
So yeah, if you expected the dot component to add component, you've kind of come to the same talk. I've just renamed it to this. The dot component is something in Angular 1.5. Add component is the migration step to Angular 2. So this is focused on, half of this is component architecture, and the other half is kind of how we implement some of these concepts in Angular 2. So a quick show of hands, who's used or is using Angular 1 or 2? Cool, 60%, something like that. So is it, out of interest, who's upgrading or is using Angular 2 from those hands? So a few people. Who wants to upgrade? Cool, brilliant. So it's actually not as daunting as you think. If you do have any questions, I'm putting together quite a lot of resources on migrating from Angular 1 to Angular 2. That's my Twitter handle if you want to ask me any questions anytime. So I currently work at a company called Telerik, who, I need to show this t-shirt, otherwise I don't get paid. Part of my day job at the moment is kind of raising awareness on Angular 2 through ng-migrate. If anybody's heard of this, then free hugs. So ng-migrate, you can Google this and find the website. What it is a collection of Angular 1 ideas and concepts. So if you know a controller, for example, you can click on controllers, and we would have some articles on there that allow you to learn how to do the same in Angular 2. So this is an unofficial migration guide, which I've been working on for the last few months. So the talk overview. Component architecture, this is kind of new to the Angular world because we didn't really think about components. We had these directives which were components, but we didn't really use them as components. Directives to these packaged contents that we kind of made a mess with. So we're going to talk about component architecture from a conceptual level. So even as if somebody was a non-coder, they would probably be able to understand the concepts of what we'll be talking through. And with component architecture, we also have the types of components. So it's not just that's a component, and hopefully it all works. So we're going to understand the thinking behind how we would architect like an application. One-way data flow. So this has been introduced recently in Angular 1.5. Thanks for joining, a bit late. One-way data flow is like the standard in Angular 2. So now we have it in 1.5. We're kind of stuck in this weird situation where 90%, maybe even more, are not on 1.5 with Angular. So we've got this two-way data flow and these thousands, well, hundreds, millions of pounds or dollars or wherever you're from worth of applications which need or hopefully will be upgraded at some point. So trying to understand how to do this upgrade. And I think the key here is the components. So, hello. So we'll go through these. So after we've covered the first three, what we'll then do is look at the Angular 2 implementation of the above. So for anyone who's never heard of Angular or Angular 2 or Angular 1, it is essentially a JavaScript framework which kind of pioneered from the moment it came out. It went absolutely crazy. It's used by millions of developers today. And Angular 2 it's had a rocky entrance, but we've finally got there. So has anyone been following the release candidate crisis of Angular 2? Yeah, the routers and form APIs, rewrites, and so yeah, it's been an interesting couple of months while Angular 2 has come out of alpha and beta and the release candidates. So we essentially have this ginormous framework that we can build very, very powerful applications with. But the Google team kind of want you to understand that it's not like just a framework. It actually, it's kind of like a fake framework, if that makes any sense. So you would go ahead and write like an Angular 1 application, and you know that what the template and the JavaScript you've written is the stuff that's actually in the HTML. Whereas with Angular 2, it can actually transform all of your templates. So instead of waiting for the document to load and then jumping on and adding behavior like click events, it will actually do these before it gets to the DOM. So everything is kind of done before it hits the HTML, if that makes sense. So Angular, we'll talk about loads of the benefits of this at the end. So one of the things that they wanted to do is make this completely cutting edge and future focused. So there are a lot of APIs which the older browsers will just not use. Like they are shooting years ahead. So this is where they're thinking. If anybody's used like a service worker before, you can actually bootstrap Angular in a service worker, which we'll talk about at the end. This is a really nice bullet for me, is that Angular sits on the web platform. So over the last few years, we've listened to like Google, the Google guys building Polymer project, web components, custom elements, these kind of things, Shadow DOM, all the fancy stuff that we get to use. So Angular 2 essentially sits on top of this. So it uses web components by default, or can use web components by default, which is extremely powerful. It's obviously going to be component-based architecture or we wouldn't be here. Web and mobile web. So we're coming out of this phase now where, yeah, I've got a Knockout app or a Backbone app or an Angular 1 app, and it's where else can I deploy my application to? So not just a web application, we can actually take our code and deploy it to something like NativeScript, which is actually built, it's free and open source by Telerik. So NativeScript, you could essentially build an Angular 2 application and just compile it down to an actual native application on mobile. Similarly with desktop, there's something called Electron. I think the GitHub guys are working on this. So you can essentially deploy to these multiple environments with just a single code base where you're sharing 95+%. So there's different strategies involved of whether you want to upgrade to Angular 2 or not. So we'll rock on with some simple diagrams, which took me way too long to draw, 4 boxes. So everybody's probably used Google Mail or Hotmail or something like this. So if you imagine this is Gmail, what you do is you have your search at the top, we have the list down the side, we have the view container, which is somewhere where you can view our messages, click messages, press settings, etc. And we can also put our chat on the right-hand side. So these containers, we can kind of think about the different sections or different components maybe of the actual application when we start building. I think, well, everybody codes in a slightly different way, but when you sort of get a new project, you don't really want to think about it, you just want to start coding and writing all the cool stuff with the new tools that you can use. So this is kind of a breakdown of how we can think about what we're going to be building even faster so that we can get coding even faster. even quicker. So if you imagine we have this chat box, now there's a few features, and components should ideally drive some kind of features or reusable logic. So if I am viewing my chat profile in Google, I might have my photo, whether I'm online, offline. We have these green, orange, red sort of symbols that indicate whether we're online or offline. Now, inside of that as well, we also probably want to display a list of friends. So we've got two ideas for components right now. And finally, we would have like a chat search. So we've got a main component. We're going to say this is our chat component. That's a building block of the app. Inside of that, we've got the profile where I'm going to have my online, offline, my profile picture. Chat list, which will render the friends, and then the chat search, which will probably talk to the list. So when we start typing somebody's name, it'll then start looking up that collection. Now, the easy part of component architecture is that everything is a component. So that's the first step out of the way. So the idea here is that chat is kind of like the global wrapper component. So nothing's leaking outside of this. And this was quite a difficult design to achieve with like when we treat applications as like views. So if you're building like an Angular 1 app that's not with components or it's proper directive structure, not directory, then it makes this encapsulation quite difficult. And the idea is that every single piece is an encapsulated piece of logic. So what I try and compare this to is like functions, for example. So if you had a function that you decided after you've made a mess in 200 lines of code in one big function, you want to break it out into small little pieces. So this is how I try and think about components. So the way that we would pretty much render this is we would create a chat element and all the corresponding other elements. So these just map across horizontally. We can create a custom element called chat profile. We can create one called chat search, chat list, and then chat search. So these are basically web component custom elements. So these allow us to, if we could spend all day talking about Shadow DOM and the Polymer project. If you are interested in what web components can do for you, I'd highly suggest reading the specifications because they're extremely powerful. So Angular 2 will allow us to create these custom elements and actually use web components to the fullest. So just as a final thing before we actually carry on, this is like the rendered DOM tree. So we have this parent component up here, and we're saying that these three are going to be child components. And you can see, even though I did design it this way, you can see that nothing is going out. So everything is just a single piece, and it communicates down a tree. So this is quite simple, and it allows us to actually go, okay, I can just take a piece of paper and I'm going to draw some boxes of what our app is going to be. Whereas, I used to be terrible at development years ago, and we used to just jump on a page and we'd code the whole thing up and it would work perfectly, and then the customer would say, oh yeah, but can we use that page somewhere else? I'm like, no, sorry. So you end up having to refactor it or copy and paste the whole thing. So when we actually break things into components, we can actually start to think about reuse. So that makes them really, really nice to work with. So the types of components, who knows what a stateless component is? One. I know Max at the top does. Just keep it quiet. Two. Stateful components, probably the same people. So in Angular, we do have the concept of three different kinds of components, which is the third one would be a rooted component. So it has some kind of routing logic bound to it. However, we're just going to focus on these two. So what we're going to do is, now that we kind of think that this is a component, this is going to be a component, this one's a component, we can start to think, is it stateless or stateful? Now, my job here today is hopefully to teach you the differences between the two. Especially if you're upgrading from Angular 1 or another framework, or you're considering something like React or Angular 2, everything is stateful, stateless components. So, a stateless component, what I try and think about these, you don't even have to think about Angular or a particular framework. What I try and do is think about these as functions. So when you write like a JavaScript function, you have some arguments that you pass into that function. Now, if you had arguments as a comma b, you could return a plus b, for example. So this could be an add function. So in that function, we would call that a pure function. So it doesn't actually communicate with variables outside of it. Whereas if we had the function arguments as a comma b, and inside the function we did return a plus b plus c, and c was outside that function, that would technically be like a bad sort of design. So the way that we can think about these is making them pure. So whatever we pass in, we always get the same result. Now if we were unit testing this add function, we would have to actually create like a fake instance of whatever the C variable is. So the idea behind these stateless components is that you just pass data down into them, and they do something, and they pass it back. Now, if you did this 50 times, you would always get the same result, given the same data. So an idea of this would be, if we go back to Gmail, for example, once you've loaded your inbox, you get this big block of your list of emails, and every single email is rendered. So ideally, these would be stateless components. So they're just like a container that would take data and just display it, where it might bind an event and pass a piece of information back up to like a parent component. So with our list of emails, let's say I had 5 emails in my inbox. They're going to be stateless components. So they would probably each bind like a click event, and when they actually are clicked, we have this concept, which is this bullet point here. We have this concept of an output. So let's say I've got 5 emails, and they have a unique ID, 0, 1, 2, 3, 4. Let's say I click on number 5, the ID is number 4. Now, what we've probably done in the past is at that component level where something is clicked, we would then make an XHR request or fire an event like crazily and hope for the best somewhere else in our application. And then perhaps change the URL, transition to the new view. So the idea here is that we would just pass the actual ID of the email that is clicked up one level, like this component tree that we have. So then it's up to this component to actually do something with this ID. So you've got this stateless component that does nothing, it manages no data. All it does is have a click event, for example, that when clicked, it passes it up. And it passes it up to a stateful component. So if we've got a stateful component with a callback that's listening for some kind of like on email select, like a function, and through the function arguments, it will get an ID. And then you can do this dot my service dot go to email and then pass in that ID, something similar like this. So the idea is that the stateful component is the driver. I actually tweeted something the other day saying that the engine of a car is like a stateful component because it's doing the driving with the pistons, the power, it has the fuel, and all the magic happens in the engine. Whereas if you think of a stateless component as the wheels on the car, it's a bit of an abstract one, the wheels do what the engine says. So the wheels, they don't really drive themselves, they don't spin on their own, they're driven from the engine. So all this, it's kind of like engine, wheels, if that makes sense, compared to the other diagram. So stateful components, they do all the work. This makes all of the logic happen in one place. So if you've got 3 different stateless components, they can just tell the parent what to do. You haven't got all these different pieces of logic scattered everywhere, which can create a mess. So one of the points here is that they render child components. So typically a template for a stateful component will just have a definition of some more components. I know that when we used to create these applications, we would have a view which would be like /dashboard, and you would have 2,000 lines of HTML with crazy stuff inside. So nowadays, if we had /dashboard, you might have like, I don't know, dashboard graph component, dashboard sidebar component, and it would just be the structure of what goes into all of the page from a high level. So what ties in nicely with this is the concept of one-way data flow. So if you're not using something like Angular, like React, I don't think they have the concept of like a service, but there is a way to fetch data and pass it into a component. So in Angular, 1 or 2, it doesn't matter, we have this idea of a service. Now, a service can be injected into a specific component. So let's say this component here, what we're going to do is inject this service. So we can inject it into the function constructor and then essentially bind it, and it becomes part of that component. So this component here can essentially request some data. So it's going to say, okay, we use a to-do list or something. I'm going to go and get my to-dos from my to-do service. So this service then goes back to the back-end API. It brings back some results. And now this container here now has everything you need. So it has all of the to-dos that are left. It might have a few different API responses. It's completely up to how you build. So the way that we do this information binding is called property binding. So this is actually pretty interesting. We'll dive a bit deeper when we actually jump into some code. The idea here is that, let's say with the to-do list, you need a few pieces of functionality. You want to add a new to-do, you want to delete a to-do, you want to mark a to-do as red. So these behaviors can be split out into different components. So let's say this is just our wrapper component for the to-do, it's just a container. Now, when we think about adding a to-do list, we need to say, okay, if I was writing that logic in pure JavaScript, it would probably be its own function. So what we would do is have this add to-do function, which we can then conceptualize as a component. So I would create an add dash to-do specific component that we just pass some data in. The user can type something, press submit, and then at this point, we can then pass it back up to the stateful component. It can then go and create it with the server and bring it back. So it doesn't really matter how many components you have. We can just break up these pieces of functionality. You can have stateful, stateless, stateless, or even stateful, stateful, stateless. Like if this needed to be dynamic in any shape or form, that's perfectly fine. Although I don't think there's probably many applications where they just have one component all the way down. Like if you think of some of the complexities of like Google Drive would give you with the upload components, there's probably a lot happening there. So this is the idea of one-way data flows. It comes down from the top, and we just pass these pieces of information that we want into these components. Now, going back, when we add a new to-do, how do we, let's assume that one of these down the bottom adds a new to-do. How do we actually go and tell the parent component to add this to-do, or to register it at the back end to create it for us? So we create these things called events through event binding. You can do this in Angular 1, Angular 2, React, all the other fun frameworks. And essentially we just pass it all the way up to the top. If you've used something like Redux, there's ng Redux in Angular 1. For Angular 2, it's probably recommended ngrx/store if anybody's using that, which is an observable-based Redux. So that essentially would allow you to not pass it up per component at a time. You could essentially go all the way around and then do the logic like an add to do somewhere else, which would then tell this top component, which would then re-render, but we won't get into that in this talk. So I like to kind of teach the framework features first, and then you can add something on top of it, should you see fit. So we've just added a to-do here. Now we're going to pass it up to this component, perhaps. Now this component also needs to tell this component, so we just get this little chain of events that happen. And the ID for the to-do, perhaps, is located at the top. So hopefully that makes some sense. We'll do questions, tweets, whichever after, whenever you have a question. So to actually get something, what we're basically going to do now is look at how we implement these ideas in Angular 2 to create this chat box idea that we looked at the beginning with the chat profile, the chat search, and the list of friends. So to create a component in Angular 2, all we need to do is import component. We can import on init as well, which is a lifecycle hook. So Angular 2 is kind of making TypeScript very, very famous. Everybody has switched to TypeScript. I've switched to TypeScript. I'm not very good at that yet. Not that good at it yet. But essentially what we can do with these, such as on init, is we can use these implements, which is a TypeScript. It's not ES6. This isn't ES6 class. However, it's implementing this interface called onInit, which we can then call this function here. We'll dive down to that in a second, though. So we can import the component, which is a decorator. We can import onInit, which essentially will run when the component is ready. And these were one of the things that in Angular 1 we struggled with, because our directives were these concepts of components. However, they had no life cycle. We didn't really know when they were destroyed. We don't know when the component was ready. We didn't know when some data changes. We used to use these scope watch and horrible hacks. So now the lifecycle hooks are here, things are a lot more predictable. Has anybody used decorators? It's this little @ sign at the beginning of component. A few people. So decorators, I'm not sure what stage they're at, but they are likely coming to the JavaScript language soon. By soon, it's probably a few years away. Angular the team have been working with TypeScript to basically implement these future features, so we can actually start using them now. So all a decorator essentially does is decorate this ES6 class, where we've got export class app component. So it kind of adds some metadata to that particular class. So at runtime, Angular can basically do a lot of optimizations for this. So starting from the top, we can create a selector. We're going to call this app. That would allow us to then register a custom element with Angular. So we're going to create just an element called app. Now the template is probably self-explanatory. We can use an ES6 string and just pass in our template. Then we've got this interpolated message here. So we've just got message, which, as you can probably guess, matches up to this .message, and that is hello world in Angular 2. So this is kind of what we need to create like a base component. So what we're going to do is like extend this component and actually build out conceptually this chat component. So before we go ahead, what I'm basically going to do through these is create the file imports first, and then we'll dive down, and then import, and then we'll dive down. Otherwise it's too much back and forth. So pretend that we've just created this TypeScript file, chat.component.ts. What we're going to do is import it. Now, there is a concept in Angular 2 called an ng module. Much like Angular 1 has modules, Angular 2 now has modules, which is just a decorator which tells the particular module what dependencies live in that module. So if you have like a dashboard module, you can import all the dependencies to that particular module, and they become sub-modules of like some higher up master module. So the idea behind this is that we can lazy load particular modules at runtime or post runtime, so that you're actually deploying very little Angular 2 code until you actually need it. So this is the idea here. So this chat component import will actually live inside a module. We're just going to add it in here just so you can actually see what's going on. So once it's been registered, we can actually just create this custom element called chat, which is pretty simple. Everything inside of here can adhere to the web component specifications, which is extremely powerful. So what's next? From the top, we want to create, well, what we basically got is an app component, which is like a base. We could add some routing in there if we wanted to, navigation. And then we render in this chat component in the center. So what we're actually going to look at now is inside this chat component. So there we go. So in the blue boxes that we showed at the beginning, we had the profile, the search, and the list. Well, guess what? We've got the profile, the search, and the list. So we can just import these again. We can register them with the module, which I haven't included here. And all we can do is just simply declare 3 particular components as child components. So one of the things that we might want to do is actually add like a div wrapper. But everything is basically just a component inside the stateful component. So these will then be stateless because they're not going to power data, they're not going to like mutate the state directly. So what we can do inside of here is we can also implement this on init. So this stuff should go inside ng on init because it's not the same as like a constructor. what you'd use a constructor for is like injecting a particular service. So if we had a chat service which we wanted to go and communicate and go and fetch a list of users, this would go in here. Then inside of here, we would actually make the call to the chat service. So the constructor is basically for wiring things up, wiring up dependencies, and ng on init, we can actually start to do something with those dependencies. So let's assume that we've made some requests at runtime inside our ng on init. We're not going to dive down into service level deep and pretend to split out requests, but let's just assume that we get 3 requests back. We get my user object, and we're going to bind it to this.chat user. It says I'm online because I've just logged in. We also have a chat term and the chat friends, which is just an array of objects, which I'm sure you can imagine is URLs of pictures of friends, their name, and whether they're online or offline. So what we'll actually do is, now we've got 3 requests, we can actually think about how we're going to split these pieces of functionality up. So we'll start with chat user. We have 2 properties. We've got name online, which is just a Boolean. So if I'm offline, we can change that to true, false. I do know JavaScript, I promise. So essentially, this is where things get really, really nice. I wasn't really sure on the syntax for probably nearly a year. And once it kind of clicks with you, you kind of understand it. So before we kind of dive into the syntax level, we've got this.chat user, and you can see I'm just passing it in here. So that's how we match these 2 up. Now, the interesting part is we're creating a property here called user. So inside the chat profile, we will be expecting an input of data called user. And it doesn't matter what it is, it's a hard-coded input, but the data to that input could be completely dynamic. So the interesting thing is why these square brackets. So with Angular 2, they actually did something really interesting, which allows them to bind directly to web components or non-standard elements, for example. So what you can actually do, let's assume this was a div. In plain JavaScript, you could do div.innerHTML equals hello world to inject that piece of text. So it's basically that kind of concept, but in a template. So under the hood, Angular will actually create a property on this component called user. So it'd be something like this.user equals chat user. What you could do is change this to inner and then capital HTML and then equals hello world on that particular component. And when you do the curly braces to interpolate text, this is actually just sugar syntax for div square bracket inner HTML equals the string. So it's using property binding, proper property binding in JavaScript to do this for us. So this makes errors and debugging so much more predictable. The error messages are just incredible from this because it's just plain JavaScript property binding. So let's move on to the next one. This one's a bit of a boring one. We're going to start with an empty chat term, or you can pre-populate this if you wanted. Again, we're going to just pass an empty string. This is probably the most boring component of the 3. We're going to bind an input called term, and we're just going to pass in an empty string here. And then we're also going to render my list of friends that have just come back from a server response. So we go up to the chat list, we create an input, and we bind the chat friends. So you can see here that there's no other logic. I've got this container of data. I'm just saying you need this piece of data, you need this piece of data, and you need this piece of data. So what this allows us to do is basically, when something changes in one of those child components, we can actually get that change passed back to us. So again, we'll just reference these quickly. We've got the user, the chat term, the chat friends. Now, in an application, everything must do something special. So let's assume that with the chat user, where I'm online or offline, I can then change my status to offline. We can even implement away, hidden, invisible. So I'm going to create a status change callback on this component. So this component then wants to know when something has changed in the child. So the child will then tell it when it's ready, or when you set it up to do this. It could be a click event or a blur event. It will fire this callback, and the change will be emitted as a function argument here. So all the logic is taken in one place. Again, we have the onSearch change, which if we start typing somebody's name to try and search them, we can then start doing something. We could filter the list of friends in here, or we could do absolutely anything. If we've then perhaps filtered a list of friends and the person you wanted to speak to has just come up at the top, we can then have a click event which says I want to chat to a user with a unique ID of 357. So when we click on that user, we could get this event object passed back to us, which gives us the unique ID as something like 357. So at this point, we could then communicate with the server, and the backend might say, I want to open a connection with this person. That person then has their little box pop up saying, Todd wants to chat with you, and they decline it very quickly. So the way that we do this to implement these, so we've got the data all above, and then we're just creating these public methods on the actual classes. So we can do onStatusChange, and we're just going to pass this in as a different binding to an Angular 2 component. And you can see this is a small piece of Angular magic where we're just saying I'm expecting an Angular event object here. Now the rounded brackets here are creating what we call an output. So the square brackets are an input, they're passing data. The rounded brackets are an output, they're expecting to pass data out. So this, by clearly looking at a component and knowing those differences, you can say, oh, okay, that's a piece of data going in, that's a piece of data coming out. So this syntax is really, really handy. So we also have the search change. Again, we can go ahead and bind this. And we have the contact select. We can go ahead and bind this. So when something changes, we can obviously populate these particular functions with all the logic at runtime. So let's dive one level deeper. What we'll actually go and look at is this one here, the chat profile component. So we're just kind of creating a tree of components at the moment and binding to them, just to kind of introduce this component architecture setup for Angular 2. So there's a couple more things that we can import from here. We've obviously looked at component on init. We have this on changes. Now we talked about inputs and outputs as well. So when I want to mark something as coming in as an input, we use this input decorator. When I know that something's going to be an output, we use an output decorator. And these two essentially play hand in hand. So we use the event emitter to tell the output when to actually fire a change. So we'll actually look at this in a second. So this is some TypeScript. Does everybody like TypeScript? Probably. Some people like TypeScript. So I think types will land in real ECMAScript soon. So yeah, I'm trying to get in there while I'm useless at it and ask silly questions. So I'll flick between the two. So we've got this chat profile, we've got the user. So this is an input because we're using square brackets. Now I can just mark this as an input here and just say user, and it's going to be of type object. Now, when I want something to change, we also have this status change, which is this one here. So I'm essentially creating custom JavaScript properties that Angular 2 can bind to. So here it's expecting an object, it's going to bind to this word user, and here we are creating a new instance of the event emitter. So this will essentially bind the event object to the status change output. So all we need to do is just call the status change as a function with a new piece of data, and that automatically goes and tells the parent. So this is really, really nice. Something else we can do, in the on init, we can just create some simple predictable property like the user status, and we can just toggle whether they're online or offline. So this isn't something you would change from inside. So if, for example, I decided to go offline and I was online, I wouldn't mutate that state directly in this component. what I would do is pass the new object back up to the parent. He would then communicate with the server and then come back to that component and say, yes, you have successfully went offline, because if you disconnected from the Wi-Fi or something, you don't want to change the view before you've actually made the successful request to go offline. So if this online property changes, it won't actually change in this component because it's stateless. So we'd actually go and tell the parent can communicate with the server, can bring back, and it will rebind some new data, which will then cause all this to update. So we also can start to think about this concept of immutable operations. Now, you can absolutely do this in Angular 1 as well. You will, however, need to upgrade to at least 1.5.3, I think it is. So all of these lifecycle hooks, like an onChanges, so if some data changes from a parent, the child component can actually know about this. And we get this object that's going to be a changes hash. So let me get on to the next one, so we actually wire all three of these up. So let's just say I've clicked this toggle status function. Here we go, we've got an event. Click toggle status to change my status. So this will then in turn go and call this function. So all it's going to do is just invert this .user.online. Now this doesn't actually, there's no callback in here that says this .user status, which we're using here, equals offline. Like there's no hard coding in here that tells the component to update its local state. So the idea here is this status change then goes back up to this parent. So we'll actually get this online property update here. Inside this parent component, we can then go off and talk to the server, for example. And guess what happens then is that when we rebind this information in the parent, the stateful component, it will actually get passed down as a change. So this change comes back down. This is an example of how to treat this as immutable. So, for example, if we wanted to mutate locally this .user without affecting the parent, we can essentially make a clone of it. So this is what this does. It takes the user current value and basically assigns it back to itself. So it will create a copy before the component is mounted, and then you can go and mutate this data. After that, you can then press toggle status, for example, which could then fire a bigger object change. So this gives you an opportunity to basically split off the data, one-way data binding between the parent and the child for more like complex objects if you needed to. So we're pretty much there. Feel free to come and ask me questions. I've got some demos which I can share afterwards. I'll send a tweet out. I think there's a hashtag for the conference. So yeah, I'll send the demos out with a hashtag for the conference if you want to actually see these in action. So a couple of bullet points just to kind of sum up thinking. Stateful components, they kind of own the stateless components. So the stateless components are pretty much like, they're the most commonly used ones because they get reused. If you think about Google Mail, for example, you have this list of emails. Like all of that, every single email is not a unique component. It's the same template, just stamped like 50 or 100 or 1,000 times. So what we can do is delegate information from a stateful component to a stateless component. We can tie in these particular events. And the interesting thing as well is if you wanted to move to something like Redux for Angular 1 or Angular 2, using this approach will allow you to do this. So if you've got a very big application and it becomes hard to communicate across particular modules, for example, Redux is kind of a day saver. Also think about the immutable operations. So Angular 2's change detection will actually be a lot faster. It will be able to see what has changed on a microscopic change level rather than just, I'm going to update this entire object and then it will have to work out what has actually changed. One of the really cool things about the stateless components, which I should have probably put as a bullet point, you can actually change the change detection mechanism per stateless Angular 2 component. So you can say, essentially, this is a stateless component, and I want to tell Angular 2 that all of the bindings coming into the component are to be treated as immutable. So it will basically will never check this component for object changes. So it basically makes the change detection much, much faster, which if you think on a bigger application, it might have to check 50 components out of 5,000. So that's a huge, huge performance benefit as well. So just the components today. I'd love to sort of stand here for 3 days and talk about components. The next steps after kind of mastering this, the Angular 2 components, would be looking at something like NGRX store. There's also something like NGRX/effects, which I think is like Redux Saga. This is all essentially built in RxJS, which is reactive extensions for JavaScript. They're observable based. Redux, from our friends at Facebook, well, not Facebook, they come up with the concept of Flux, which Redux kind of derives from. The ahead of time compilation, I'll mention this as the final thing. So this is actually really, really amazing. When you're developing Angular 2 locally, it's actually 2 megabytes. So you've got this hello world of 2 megabytes, which is huge. When I first saw it, I was like, you guys are crazy. Like, why are we having 2 megabytes? What it allows you to do, because we're using a template and all these particular bindings and an ES6 class, Angular 2 can actually statically analyze what will happen between the template and the class, and it will basically rip out all of the code that you don't need. This is something called tree shaking. And the ahead of time compilation, it basically won't ship any of those divs or chat dash profiles through the browser, and it compiles it all down to the fastest JavaScript possible, so it can statically analyze it before it even reaches the browser. So you can end up with a 28 kilobyte, which is a few lines of code, from this 2 megabyte bundle. So they essentially ship you this huge container of stuff. They're like, use these pieces, and then we'll move it all when you actually want to deploy, which is a huge change from Angular 1. Angular 1 wasn't that big, but we can make things faster. Web workers is really interesting. I think we're out of time, so we'll talk about outside. A lot more, maybe next time. Thank you for coming.
Thank you very much, Todd. Great presentation.